Alright, well, this is my reassessment, and the problem is a highway curve has a radius of 825 meters. At what angle should the road be banked so that a car traveling at 26.8 meters per second, or 60 miles per hour, has no tendency to skid sideways on the road? Hint: no tendency to skid means the frictional force is 0. So I went ahead and wrote down my given, and my velocity is 26.8 meters per second. My radius is 825 meters. My gravity is 9.8 meters per second squared, and my frictional force is 0. And I drew my force body diagram. I have the force of gravity pulling down. Then I have my normal force going this way, and then right here I have my mass times velocity squared over radius. So first thing I did was use Newton's second law to sum of vertical components of the net force. So the sum of the force in the y direction equals 0. So I put the normal force, can you see that? Yeah, normal force cosine theta minus mass times gravity equals 0. And then I added mass times gravity to one side of the equation. Then I took the sum of the force in the x direction and I put it to 0. So that gave me the normal force sine theta minus mass times velocity squared over the radius equals 0. And I added mass times velocity squared over the radius to the other side. And what I did was I divided equation 2, my second equation, which is my x equation, by my y equation. And that gave me normal force sine theta divided by normal force cosine theta equals mass times velocity squared over the radius divided by mass times gravity. So on this side, the masses cancel out, and that leaves me with velocity squared over the radius times gravity. And on this side, my normal forces cancel out, which leaves me sine theta over cosine theta, which gives me tangent theta as a trig function. And let me move it up a little bit. So then I get theta equals inverse tangent velocity squared divided by the radius times gravity. Then I substituted my known. So I have inverse tangent times 26.8 meters per second squared divided by 825 meters times 9.8 meters per second. And that gave me theta equals 5.08 degrees. So the banking angle is 5.08 degrees. And that is my reassessment.